Welcome to East Tennessee Pinball. Today I got something really different. I was up at the American Museum of Science and Energy up in Oak Ridge. I was checking in on my space mission, and their big plasma ball, they got like a 2-foot diameter plasma ball. It stopped working. They asked me if I could take a look at it, see what's going on, and I was like, nah, I never fixed a plasma ball, but I'll take a look at it. So anyway, inside the guts was a power supply. I've worked on a few of these before, not too different than some of these old pinball machines, so I told them I'd take a look. So I'm taking a look, and I'm bringing y'all with me. And if you're somebody from the AMSE, welcome to my channel. So we're going to start this process. Power comes in on this cord here. It runs. I've got it a little bit disassembled, by the way, but not very much. I've literally got 4 bolts off, and those 3 screws hold on the case. Those 4 bolts bolt that in upside down. It goes right behind there, and then this thing board here is just kind of tucked in the side. So anyway, the power comes into this transformer. If I can get this turned around here. Those black and white wires, and it's turned off, so I'm unplugged. It goes in those first 2 lugs, 5 and 6, and 6 is actually wired into 2, and 5 is wired into 1. So you've got 110 volts AC across 5 and 6, and across 1 and 2. I looked at the part number, and that's the part number right there. So this transformer, I found the data sheet on it. So it, depending if it's either series wound or parallel wound, and I'm not sure at the moment here, it's either a 36 volt or an 18 volt that it's trying to produce. So these transformers, where they work, so like I said, I had 110 AC going across 1 and 2 and 5 and 6. So that's one side of it, and there's literally a whole bunch of copper windings. On the other side, there's a whole bunch more copper windings, and it changes the voltage from one side to the other. Those wires are not touching. It does it magnetically, and that's what these things do, and they're in all kinds of devices. So I'm going to look on the other side of the transformer here, and on the let me get some of this stuff out of the way. It's kind of messy. On the other side, there's a pink wire on 12, hard to see, and all the way down at the bottom at 1, there's another pink wire. Oops, that's not a 1. That must be that is a 7. It's hard to get it to focus down there, but trust me, it's a 7. So on the other side, there's wires on 12 and 7. That's what's coming off. So if I measure across 12 and 7, I ought to be measuring 36 or 18 volts. So I'm gonna put you on the camera so I can use both hands here for a second. Okay, I'm gonna plug it in here. That hum you hear is the fan not starting up. I'm gonna give it a little push with my finger, get it going. There it goes. That fan's really tired. It needs to be replaced no matter what. So I'm going to touch the top of this carefully because it's all energized, and the bottom. And I've got 32 volts. So that's not quite right. As you remember, I'm guessing we should probably have the 36, not, and very likely would have a little bit more than 36 because the voltage coming in here is a little bit more than in this particular location. We don't have 110. We've got closer to like 122 or 123. So we should probably have like 38 or maybe 33. The deal is that's probably not this transformer. These transformers very rarely go bad, and when they do, it's usually very obvious because they've got like a waxy substance that insulates between the coil windings, and if they go bad, it usually just belches out the bottom of them, and they look horrible, and this one does not. So this is probably good. The problem is probably downstream. this board probably has something bad on it that's pulling that voltage down. So the first thing I'm going to do is I'm going to disconnect this board from the transformer and see if that would get the voltage up where it should be, and make sure that this part of it is actually good. So I'm just going to desolder this top wire off of here. There we go. And we'll plug it back in. We'll try it again here. Still 32, so maybe that 32 is accurate. Not for sure. Well, I figured this one out. This one was really silly. It's a 130/28. I was looking at the wrong line over here. If I look at 130/28, the voltage is 28 volts, and I'm measuring 32, a little bit more than the 28, which is what I expected, so that's perfect. Okay, so the transformer's working. Next to go downstream to the board and start looking at the components on the board. Okay, so this board is pretty simple. It doesn't have very many components. It's got a fuse. I have measured continuity, which is to say I've measured the electricity can go across the fuse, and it's working. It's got two rather large capacitors. It's got another film capacitor here. It's got a bridge rectifier, which what they do is they turn AC voltage into DC. So the AC, the electricity is going back and forth and back and forth, and DC, it's only going in one direction. Like a battery has DC voltage. Two big resistors, and then one other little small resistor that is really burnt up. I initially thought that this might have been the cause for the whole problem. This one is actually still working, and I measured 155 ohms. I'm not positive that's the right value because I don't have a schematic for it, but I kind of believe that's probably right because this resistor here is in line with this potentiometer, which is a variable resistor, and this one goes to 0 to 500 ohms. I measured that just going from back and forth. At one side it's at 0, 100 side it's at 500. And this one, like I said, is in series with that. So that basically makes this one go from 155 to 655. So you don't have a 0 setting on this thing. So this, if this thing was like 0 to 10,000, having 155 here wouldn't make a whole lot of sense. But given this is 500, having this 155, it's kind of in the realm of normalcy, I think. So that might be right. In any case, I'm going to swap that out, and that's probably a 1/4 watt resistor. I'll put a 1/2 watt resistor. Maybe it won't be burned up. That one itself had been replaced before, so that had burned up one time previously. These caps are really old. There's a date code I saw earlier. If I can find it, there it is. If I twist it around, 8552. So that's the 52nd week of 1985. Those things are done. I mean, these caps nominally last 10 years. I mean, they'll last longer than that, but they're well past their goodbye date. This board, I don't know if you can see underneath there, that says 2001. So that's when this board was designed and or assembled. These film caps are not as bad about going bad, and this one doesn't look bad. It's just probably all right. The rectifier, we can do a test on the rectifier, and in fact I've done a test on the rectifier, and it appears to be good. You can do a diode test on that, and I think that's good. I do believe, well, I'm not sure for sure. Well, let's plug this in, and I'll show you what I'm seeing from the rectifier. Actually, before I plug it in, here's a schematic of that rectifier. So the two inner leads are the AC coming in. So on that board, that's that 32 volts AC. So they're wired across the two inner ones, and they produce the two outer voltages, which are DC. So there's a plus and a minus. So basically, you put the multimeter on a diode check, and you put the black lead on the plus, and then put the red lead on the either of the AC currents coming in, and you ought to get a voltage measurement of about 0.4 to 0.7, something like that. And likewise, then you put the positive lead on the negative side and put the black lead on either of the ACs, and you ought to get the same 0.4 to 0.7. And if you get those measurements on a diode test with the rectifier, most of the time those things they're good. So I'm going to do that right now. So the positive lead is this far left one, so I'm going to try to get my hands out of the way, and then put the red on the two ACs. Oh, I got to put it on diode test first. There we go. So 0.505, that's between 0.4 and 0.7, so that's good. Put it on the other AC, same. Now put the red one on this side and get these two, 0.505, 0.505. So they're all very consistent and all between 0.4 and 0.7. So that rectifier is probably good. So that's the first thing that this thing is doing, is taking that 32 volts AC and producing a DC. So I'm gonna plug it in again, and I want to try to measure the voltages here. Okay, I got it turned on, so I'm going to measure. First, I'm going to measure the AC voltage on the inside coming in. There's the 32 volts AC, and I'll see if I'm making the voltage coming out on DC, and I'm making 43 volts DC. I don't have the schematics, but that seems about right. Usually when you use a rectifier going to DC, you'll make about, I don't know, 125%, 150% of the AC voltage. So that all seems good. So far so good. I haven't found any problem yet. I think what I'm going to do at this point is go ahead and let me turn this off real quick. It's kind of noisy. Yeah, the bearings in that fan are shot. I think what I'm going to go ahead and do before I go any further, I know I'm going to swap these capacitors out and that resistor too, is I'm going to swap those three components out real quick and take care of that. Because on the other side here is this bottle cap transistor, and this is a power regulator, and I suspect that this one, I'm going to jump the chase, I suspect this one might be bad, but I'm going to go ahead and get the rest of this kind of verified and make sure this is working before this thing goes off the board and deal with that. So I'm going to do that real quick. I guess I'll go ahead and film it. Why not? Here's some solder. Figure out which ones are which. And I'm going to have to get something to scrape this old hot glue on there. I wonder, so James Falk invented these things back in around 1980 and sold them to a bunch of museums. I guess he had a patent for them, or they were copyrighted or something along those lines. Maybe not invented, but and I guess this one's been in service since then. Not sure sure the polarity is marked on this board. I took them out just like that. I'm going to go ahead and mark it right now, because these big caps like this, they're polarized. So there's a positive and negative side, and they have to be the same way. So I don't want to mess that up. Actually, it's labeled on the board. Yeah. I don't know if you can see that. There's a positive mark on there. So that's good. Thank you, James. Okay, so these are 1,000 volt or 1,000 microfarad 50 volt. So let's see what I've got. So I've got 1,063. So the 1,000 is basically the capacity in microfarads. That literally relates to how many electrons it'll hold. Farad is 6 times 10 to the 23rd power electrons. So that's a lot of electrons. So 6 times 20. It's Avogadro's number. Basically, Avogadro's numbers times 1,000. And 63 volts is, how much voltage, or I think about it like in terms of pressure. It's how well insulated the different layers are. So I'm gonna get this thing flipped back over. Unfortunately, most of the modern capacitors are not their radial, so both leads come out the same side. They don't make many these axial ones like this anymore. I'm gonna have to suck the solder out of there yet. Solder sucker. This one's going to be tough, the one underneath the plastic here, or the hot glue. I'm not sure I got it or not. Yeah, I did. When I emptied the gun, it was pretty full. Gonna have to make these a little bit longer. A little longer yet. Okay, I'll just solder those up real quick. This thing just kind of lays in the case, well, vertically, but I don't want anything. There's not much clearance, so I'm gonna trim these things pretty short. All right. In fact, I may have to find a new place for it with those caps. They're not going to fit back where it was. Well, need be, I'll get some axial caps. So I'm gonna, let's go ahead and take this other one off, this resistor. I think what somebody did, they cut the old resistor off and they left, yeah, that's what they did. So when this thing died some years ago, they cut the old one off, left the leads, and soldered the new resistor to the old leads. So I'm gonna try to get those out of there if I can. Oof, that's pretty hot. Imagine that. I'm gonna get a pair of tweezers. All right, pack some tweezers. You can see how much heat this thing generated. It's all, the board's a little burnt. So where's that resistor? Here's that resistor. It's pretty burnt up. So I'm replacing it. I was measuring 155 ohms. I'm replacing it with a 150 ohm. This is a 1 watt resistor, so it should not burn up. Looks like I can go through either set of those. I'll go through the wide set. That'll give that, have a little extra cooling, that wire. Okay, just for fun, or just out of being prudent, I'm going to make sure I didn't screw anything up. I'm going to measure the voltages, the AC and DC voltage, the AC going into that rectifier and the DC coming out. I don't know if you can see that. There, you can see that there. Before we go any further, so I'm on, I'll just measure the DC. If the DC is good, I'm pretty sure the AC is good. 43 volts, okay. So we still got our good voltages. And we've got no no AC ripple on our DC. That's what those big capacitors are for. I guess I didn't show you that, but I did measure that off camera, and I had about a 0.5 volt ripple on the DC, AC ripple on the DC before. So these capacitors here, that's what their job is to basically smooth the DC so you get rid of the AC ripple that's still in the signal. All right, okay, so now I guess off camera I measured the resistance on these. They're as stated, 27 ohms and 1,000 ohms. I think everything is on this board is good. So there's this last piece of the puzzle here, which is this power transistor. So these, most of the pinball people know this, but maybe the museum people are probably newer to the electronics, at least some of you. So there's 3 legs on this, and it essentially acts as a switch. There's I don't know if you can see it, but there's a B and there's an E, that's the base, and there's the emitter, and the center leg is not labeled, and that's the collector. So the collector is where the power comes in, and the emitter is where the power is emitted. I'm sorry, the base, yeah, the collector is where the power comes in, emitter is what emitted, and the base is what controls it. So the yellow wire is the signal that basically opens and closes and allows the electricity to go from the base to the emitter. So essentially this is a voltage control device. So I don't have the schematics for this thing, so I don't know. So you get that 43 volts DC that's being made. This is regulating it some predetermined voltage. I've also, again, just looking at the wiring through the system. You've got that big potentiometer here off the side. It's involved with this, with its yellow wire here, the base wire. So I believe what you're doing here, you're controlling this voltage regulator here with this. So what we should be seeing is, I'm assuming just by kind of looking at this thing, is by rotating this potentiometer, we should be able to change the voltage coming out of the emitter. I've cheated because I've already looked at this a little bit. It's not doing that. So I'll go ahead and show you what I'll just do it again here and show you what I've found here. Well, I found some things that weren't great on this system, but I haven't found the smoking gun yet. I'm going to do a diode test on this transistor here. So just like the other one, between different leads, you ought to get a reading between 0.4 and 0.7. With the red on the base and the black on the other two, I ought to get that point. Well, so there I've got, get my hand out of the way so y'all can see, about 0.5. Get it steady on there. Not making good contact here. I think you probably see it's like 0.49, 0.5. Well, maybe not. There we go. There you go. There's steady. 0.485, and on the other lead it's completely open. There's nothing. Between these two it's open. So I swap them around. So between all combinations, this the emitter here has no electrical connection to either of the other two. So I'm pretty certain this is a bad transistor. So that's good news, because those it's a fairly cheap part and still available. And so I'm gonna order one of these. Probably order a new fan too, because that fan is shot. And maybe in a week I'll plug it in. And actually, I'm gonna do one more thing. I'm going to go ahead and test this out of circuit. I'm going to cut these with a little bit of wire showing so I can make sure I get them in the same place. when the new one shows up. I'm going to check it out of circuit, because sometimes having it in circuit will give you craziness because you've got all this other stuff in parallel. And that did not change anything. So yeah, still showing as bad. So I'll get a new, order a new 2N 3055 power transistor, and maybe I get this, get that in this field video. Order a new 2N 3055 power transistor and get this plasma ball up and running again. Hope you liked the video, and well, actually, for y'all, this next week will be about 2 seconds. 3, 2, 1. Well, it's been a few days. I got my new 2N 3055 in, so I'm going to swap it out. I'm going to pull this one out, and, well, actually, before we do anything, let me put this same orientation, and let's test it just like we tested the other one, and just make sure that what we thought were bad readings are bad readings. Give that sound diode test. Yeah, see, between this left leg and the case and the right leg, I've got that 0.5, 0.45, 0.5 on both of them. And on this one, I did not. So for sure, absolutely for sure, that thing is dead. So will this fix the plasma ball? I don't know, but this one would have to be fixed for the plasma ball to work. I would say that. So we'll take this out. Oh, yeah, this thing. Oh, no, it's. I need my glasses so I can see. I think the pins are just. The pins on there, I don't know if you can see that, but they're just. I believe they're just pressed in. They're not soldered in, so I'm going to have to, like, kind of pry this thing out. Yeah. Surprised there's no thermal compound. Well, it's a little greasy. I don't know. Maybe that's not any kind of thermal compound I've seen. Anyway, I'm going to put a little thermal compound on there. There's really no good way to do this without using your finger, I think. This stuff is just messy. This is not laying down well at all. Maybe a little dried out there. Yeah, I got down to some fresh stuff there. See, these will be easier to, well, it'll be easier to desolder now, but if I take them off too soon, I might get them mixed up, so safer to put them on, do them one at a time. Q-tip and clean that up just a little bit. Thermal grease is the nastiest stuff. It just spreads forever. Like Dean apple for those in the know. Alright, so now we need to get all this out of the way. Throw this way, dead. I'm going to grab my other wires and we'll solder this thing up. Alright, so I got my 3 sets of wires. Just strip these back a little bit. And before I try to solder them on, I'll tin them up a little. Does not want to lay down. Desolder this green one first, okay. Green one's off. Probably focusing on my hand, not on, but not much to look at. Okay, green one's done. Take the blue one off. Throw a little fresh solder on the blue terminal or lug. Alright, now the yellow one. Almost got too much, almost touching right up there at the top. I'm gonna have to redo that one. Yeah, I got a little too much solder on there. I'm gonna suck a little off. Soldering is kind of like welding. It's positional. Some angles are more difficult. All right, so we don't have the plasma ball here, or I should say I don't have the plasma ball here, but we've got the entire power supply. So what I'm guessing is that when we plug this thing in and turn it on, let me get more of this in the field of view. So this is pretty much the entire thing. The only thing off over here is the fan. Yeah, y'all can see everything. I got my little knob here. You can't quite see the knob. Let me scoot you in here so you can see the knob. There's the knob. This is the gain of some sort for the entire thing, because there's a note attached to this blue line that goes that it goes through, that reduced power setting for the public. For demonstrations, you can crank it up. I guess you can make your hair fly up or something. I don't know. make a really good show if you're doing it on yourself. I don't know exactly what we should be getting, but for sure, I believe it was the yellow one. Which one's the E? So the green. The collector is the bottom there. E is the one, the emitter. That's one. I'm assuming that's what's going up to, ultimately going up to the plasma ball, I believe. Not positive. So I'm gonna plug this thing in and we'll turn it on and we'll see if we got some voltage from E and if we can indeed tune it with the knob. If we do, then I'll feel moderately comfortable that at least this part is working. So first thing I'm gonna do is plug it in. Hopefully we don't smoke it. Give the fan a little encouragement. Okay, the fan's running. When I say encouragement, I give it a little twitch. Okay, so I guess I've got this, well, I don't know, maybe it's running on negative voltage, I don't know. I'll turn it around, it'll look like we got positive voltage. So we got our, this is our base, this is our one that controls it, so it's at 43. Let's turn it way down. That does nothing. I was kind of expecting this to control the base. That's the emitter. It's emitting 43. I know you can't see the multimeter. I can't get it all in here. That's 43. If I turn it all the way the other way, it's 43. And the collector, yeah, that's, oh, okay, so maybe they're running this thing backwards. They're doing it the opposite direction. So the collector is about 2 right there. And it's still only about 2, well, yeah, it's about 2 volts. 1.9, jumping up to 2 every now and then. Go the other way one more time. I don't know. Doesn't make quite sense to me. It's about 1.8, so it did change it slightly. But for sure, we've got both voltage on the emitter and the base, and before we did not. So for sure things are different. Like I said, I don't have the schematics for this thing, so I don't really know how it operates. I guess the thing to do now is put this thing all back together, take it out to the lab, or not the lab, but to the museum, and plug it in and see if it works. So downstream from this, there's got to be some kind of a voltage amplifier, some kind of a transformer of sorts. But usually these things run on several thousand volts. Let me unplug this. I would expect it to be a couple thousand volts anyway. And there's nothing here, you know, there's nothing here above, well, there's 110 AC coming in, and then it quickly converts it to 43 DC. And then beyond that, it's just regulation. So that's really all this thing does, that I can see anyway. So anything, there's downstream, there's a couple units in, there's the ball itself, and right beneath the ball, there's another really strange looking unit that I didn't didn't pull out and didn't. It looked like it was fairly well attached to the ball itself. So I was kind of suspecting this would be the problem, and obviously there was a problem. And very hopefully this bottle cap transformer is all it was. I give it about an 83.425% chance of fixing the issue right here. If I've learned one thing from teaching engineering, excessive significant digits are always warranted. So I'm going to stop it here, and maybe in a couple days, well, I'll plug this thing into the unit and we'll see if it works or not. Maybe it will, maybe it won't. Anyway, if you like the video, subscribe. Actually, I need to save that for the end of the video, because the end of the video is going to be a few days from now. We'll plug it in and it's going to be awesome or it's going to be failure. One or the other. Anyway, so hold on. It'll be just about 2 seconds. Just one little addendum here. I was just looking at this a little bit more off camera, figuring out why this rheostat here wasn't doing anything. The way it's wired is basically this is the last thing in series before there's this, it's hard for y'all to see, there's this plug here that goes off to the plasma ball. Actually, there's some sort of transformer to get the voltage up and then to the plasma ball, but it leaves this box, let's just say that. And this is the last thing it goes through before it leaves the box. So this is the current limiting device before it leaves here. So this is not going to really control the voltage unless there's some current going through it. So it's really a current limiting more than voltage limiting. So it goes through here and then it goes directly to this plug. So we're not going to see the effect of this on here is basically what I'm saying. So the fact that this is not controlling this like I thought it would, that's so I'm going from whatever 85.23 whatever it was. I know that was very precise, and I ought to remember exactly what the number was, given that it was that precise. I'm jumping it up to 93.27576. Okay, so we'll see you in a couple of seconds. Well, I'm here back at the lab, or not at the lab, at the museum. I always called the lab. And this is the plasma ball. It's big. You see my hand there. It's about 2 foot in diameter. Getting ready to, this whole thing comes off and put this power supply back in there, and we're going to see if it either turns on, stays off, or blows up. One of the three.
Hi, I'm Quinn from the American Museum of Science and Energy in Oak Ridge, Tennessee. Today we are trying to fix our plasma ball. We're here with John Tyner of
East Tennessee Pinball.
East Tennessee Pinball. I was forgetting that for one moment. So he's been helping us with this. In fact, he's actually been doing all the work. He's not been helping us. He's been doing the primary work. We're going to try flipping it on in just a moment. I'm going to let John.
What you don't know is they've already seen 20 or 30 minutes of me working on this right by now. So
wonderful.
They know everything. They know a lot more about this than you do at this point.
Okay,
all you got to do is hopefully turn that knob, and maybe it'll work. Maybe it won't. It should click one way or the other. Is it turning?
It is turning, but it's not doing anything.
Well, maybe it doesn't work.
Oh, wait, maybe.
Oh, I heard it click.
I heard it click, but I think that was the other end. Yeah, I'll let you look at those too.
Well, that's not good news. That should be on high there. That's in there. Well, still dead. We just had got no gas moment here. We didn't have it plugged in.
Okay.
Okay, so we're gonna plug it in, and then wait. Let's see that it's turned off. It's turned off again. Okay.
Yeah, I'm gonna move this one back so it's not.
Yeah. I was all disappointed. I told everybody it was 95.7243% chance this was gonna work.
Well, now we.
Okay.
Okay, ready?
So now it's plugged in. Okay, so now I'm gonna let you do it because I don't want to kill myself getting shocked. Oh my gosh!
We already had it on apparently.
It's working. I think you need to turn it up a little bit, maybe. Can you crank up the?
Yeah, I'm going slow.
Okay, now it's touching my hand. All right, that's awesome.
Making noise, yeah. You want me to crank it all the way?
I don't know. How high was it before?
There we go. That's cranked all the way. I had said low, but I'm thinking this is kind of awesome. How is it shocking now?
You can't feel it at all. I can't.
I can't. Although maybe the Van der Graaf takes a moment to charge up, and then it starts. Maybe a little.
I was all disappointed it wasn't working. I was like, what's this plug? Wasn't even plugged in. Oh my gosh.
Maybe it does give you a little here. Let's see, that's...
So what we're playing with is this little rheostat down here. I'm going to show you the underside of this in a second. I still don't fully understand how this thing works, because this thing is supposed, from what I've read, these things generally work on about 2,000 volts AC. And I don't see anything that's making the AC for this, much less a 2,000 volts. There's got to be a transformer of sorts underneath here. There is one little device, but I don't quite fully understand it. And I'm thinking maybe this is have a DC that's interrupted DC, so the DC is on, off, on, off, on, off, on, off. And so it's kind of like an AC, but I'm not positive about that. Somebody that knows more about it should comment down in the link. But anyway, I'm just... regardless of what I know about how this works, I just knew barely enough to figure out that bottle cap transistor was bad and get that going. So
I'm
cool.
going to note that it did not look this good before it quit.
It might not have been cranked up quite as high, or it could have been that transistor was kind of fading out over the last 20 years. So
flip it off so you can look at the bottom.
Yeah, let's flip it off and we'll look at the bottom.
Okay.
Yeah. So we'll flip it over here.
And we need some
And so
lights.
this thing was kind of a homemade,
Steady.
I wouldn't say homemade, but it was, you're going to see some, so there's 8 wires, individual wires on this cable, and a lot of them, I first looked at this, I was like, what the heck? A lot of them are bare-ended. That is just a twist, basically a twist tie. So a lot of them are connected, those two are connected to nothing. There's a red one that comes and goes. There's a white one that comes and goes to this coil. So it's almost like a transistor or a transformer where you got a coil in a coil, a step-up transistor. I think this doesn't look like any one that I'm used to in a pinball machine. And somehow I'm thinking one of these wires maybe, and that's actually 2 wires. No, that's 1. Maybe this one goes back to that bottle cap transistor and is cycling that one on and off. But that's just my imagination thinking of what it could be. I really don't understand it. I don't have schematics and I don't recognize what this is. I can just say it might be a step-up transformer. And certainly this thing needs more than the tens of volts of DC that's feeding to it. So somewhere there's got, and this is the only other piece there is, and then this is the bottom of that globe. So that's just the basically the big stem of an electrode that sticks out the top. So that's about all there is to it. So I looked for some numbers on this. I didn't see any. It almost looks homemade, at least like the way those wires are wrapped around there, and that looks kind of like homemade cut and like got some bolts and nuts and scabbed it together. But it's been working for 23 years, so good on them. Maybe I'll get another 23. We'll see. Thanks for watching the video, and hit the subscribe button if you like it. Cheers.